Dear M.Sc students, how are you doing today? Uh, Today, let us discuss about Heisenberg uncertainty principle, which is a very prominent theorem on quantum physics or quantum mechanics. As you know, atomic objects like electron, proton, neutron, etc., these kind of particles exhibit both wave like and particle like properties. The uncertainty principle, Heisenberg uncertainty principle also protects the wave particle duality. So according to this principle, it is almost impossible to measure simultaneously the exact position of a particle along a particular direction, and also the particle's momentum in the same direction with the unlimited accuracy. This principle is called Heisenberg uncertainty principle, which is very prominent one. So the Heisenberg uncertainty principle states that the order of magnitude and magnitude of product of the uncertainties of two variables must be at least Planck's constant divided by twice pi, and which is del px into del x is equal to h cross. Here we know h cross is equal to h by twice pi. Here h is the Planck's constant. Here del x represents the uncertainty in x, which is the position, and del px represents the uncertainty of momentum, uh, and these are represented by this equation, which is del x is equal to the expectation value of say this is number 1. Here del x is the uncertainty of position of a particle at a certain direction, and del px, which is the uncertainty of momentum of a particle at a certain direction. This can be represented by the expectation value p minus px. So this is equation number 2. While we know the expectation value of x is the position, p is the momentum, x and p are, let me write down the expectation value of x, which is the position, is equal to integral psi star x psi x, obviously dx. So this is equation number 3, where psi is the wave function, which is a function of x, obviously, and px is equal to integration psi star x h cross by I. H cross by I can be written minus IH cross as well. Del by del x, which is known as the momentum operator. I had already discussed it before you earlier. Dx, psi x dx. So this is equation number 4. And now when the momentum, now when the wave function psi is normalized and h cross by I del by del x is equal to px, which is the momentum operator, we know. Then the Heisenberg uncertainty principle states that Heisenberg uncertainty principle states that del x into del px greater or equal to h cross by 2. Here del x is the uncertainty of the particle in terms of its position at a particular direction, and del px is the uncertainty of the momentum of a particle at a particular direction as well. H cross is the Planck's constant. So to prove this principle, we need to go through some mathematical calculations. Let me discuss a few lines, and I think you better solve it by yourself. The rest part can be solved by yourself. You must go through all the mathematical procedure. Let me start. Proof. So in this case, to prove this uncertainty principle, we are to prove, at first we have to prove one thing first, which is in case of wave function psi x, we need to prove expectation value of x is equal to 0 is equal to expectation value of p. Expectation value of x and expectation value of p must be 0. So as we know, we have del x, which is which denotes the uncertainty of position of a particle at a certain distance, which is x minus expectation value x is whole square. No, yes, now this is okay. So from this we can easily write down expectation x square minus 2 minus expectation value 2 x expectation value of x and then plus expectation value of x square. So since expectation value of x is equal to 0, we can write down del x whole square. It should be whole square. Whole square is equal to simply we can write expectation value of x square. So this is equation number 6. And similarly, del px, we can write px square. So this is equation number 7. So now by considering an integral, right? Now by considering the integral, now by considering the integral and taking psi, which is wave function, is also a function of x, we can write IH cross psi star. Psi star is the complex conjugate of the wave function psi, pdx x psi dx is equal to, by doing integration by parts, we can write down IH cross psi star x psi minus IH cross del psi star by del x, obviously, x psi dx. Here we have done integration by parts. So from this you can easily interpret, you can easily deduce the uncertainty principle. You need to follow all the necessary mathematical procedure, and hopefully you will be succeed. If you face any problem, then let me know by messenger or by phone, then we shall fix the things if you have any problem. So this is all about the uncertainty principle, Heisenberg uncertainty principle, about the position and momentum, about the uncertainty of position and momentum of a free particle. So that's all for today. Till then, stay safe. Thank you.